Hello and welcome to Cute Pixel. Sorry it took me just a little bit longer to get started there than I expected, but I am here now. Start as always with my upcoming stream schedule. I stream regularly on Sunday mornings starting at 9 a.m. And hey, that's now. The project I am working on is continuing my craps table chatbot using Node.js. This connects to a chat room in my Twitch channel. I will demonstrate how to connect to that if you are interested in playing with the bot. My regular stream schedule is on Sunday mornings starting at 9 a.m. That is today. This is my regular Sunday morning stream. I also will try to stream on weekday afternoons and evenings when possible. However, my schedule during the week is not always predictable, so it's tough for me to announce those streams in advance. So if you don't want to check those out, be sure to follow, and you will get notified when I go live on those days. So as I said, today I want to continue work on my craps table chatbot. Let's go bring up my notes for that project. Here we can see the work I completed last time on the project. I've been working on a scripting engine for the bot so that players can try to script their gameplay as opposed to having to manually type every single command they want to enter to the bot. And so last time I added support. Last time I added support of multiple statements separated by semicolons so that if a player wanted to do multiple commands, they could separate them by semicolons and get multiple commands in one statement. Support evaluation of system-defined variables and expressions. So we've allowed for an expression. Expression is something that looks like this here, enclosed in those curly braces. So we now support evaluation of system-defined variables and expressions. And then I just did a very quick cleanup. I removed a blank line in the console output when the player's data file is missing. Just something I noticed. I think that was a holdover from when I updated our debugging printing. And I just wanted to go ahead and remove that. So my work today is I want to continue working with the evaluation engine or the scripting engine. This is the type of stuff we have working so far. In fact, let's demonstrate what we have working so far so that you can see what is working, what is not working. This is the bot console window here. Anything that you do in the scripting engine will be logged to the console. And then if you want to communicate with the bot, you need to actually go to my craps chat room. So we have the stream chat, which is what you're normally in, and then we have all the chat rooms. Instead of stream chat, you want to click on the craps room to get access to the craps bot. And so let's see, what does work these days? We have craps eval print hello. We can just do a static kind of hello world example here. Now we can see that we have some debugging information for what it's doing, evaluating compound statement, evaluating single statement, and then we have the print hello. That all works. We also have the ability to print or do simple evaluations, so we can do print die 1, die 2. Let's go see what that looks like here. You can see it's a much more complicated expression here, or debugging, because again, we're evaluating the compound statement, evaluating the single statement. Now we're evaluating the expression that results in a 3. We're evaluating this second expression that results in a 4, and here is the result that we print out. So that all works right now. Plus, multiple statements still work, so I think I have a multiple statement around here somewhere. Oh, we got some broken stuff. Where is my multiple statement tests? I could swear I used to have one around here somewhere. I must have deleted it. But here's an example. We could say craps eval bet. This is all the crappy bets. So we have like any 7 for max. That's a really crappy bet. And we'll say bet hop 1-1 for max. That's not such a great bet. And let's add in all the hard hop bets. So we have 2-2, 3-3, 4-4, 5-5, oops, 5-5, and finally 6-6. So this will bet on any 7 or any of the hard hopping numbers. Let's go see what that does here. So yeah, we can see evaluating the compound statement. There's the full statement right there. Evaluating single statement, bet made, 3-1, 3, 3, 3, 3, 3. So we've made all those bets. This will get resolved in the next roll here. In the meantime, let's think through what is not working. So that's all the stuff that's working so far. What's not working is we can't do kind of simple expressions with arithmetic. So like, I can't take two variables, two system-defined variables, and add them together. So if I try this, this will fail. Yeah, unable to find variable die1 plus die2, failed to evaluate expression. And so yeah, that's just part of the problem there, is the expression evaluation is really simple right now. It basically pulls out the contents of those brackets and it looks for a variable with that name. It doesn't do anything else with it. In fact, I think it's so broken that if I was to add a space to it, say craps eval print, just say die1, if I was to, so that should work. So let's just try that real fast. Yeah, so that prints 2, so that works. But if I add a space before the word die1, unable to find variable die1, because it doesn't even trim any spaces out of it. So we just have a really dumb parser that's going on right now. And my first thought is to let's make that parser smarter so we can deal with spaces, and so that we can also start thinking about handling arithmetic, plus signs, minus signs, divide, multiply, all that basic stuff. So that's today. Let's go take a look at the code. We can see why this doesn't work and start to come up with a way to work around it. So this will actually be in the scripting class. Here we have a function to evaluate a compound statement. This will split the statement based on semicolon, and then call eval statement to evaluate the single statements. Evaluating a single statement, it looks for those curly brackets. So we have code to ensure we have closing brackets, opening brackets, mismatched brackets, all that stuff. And then we have expression is equal to substring. So we get the expression start, that's the opening bracket, expression end is the index of the closing bracket. We substring the statement to get the expression, then call eval expression, and let's go see what that does. Eval expression prints out some debug for what we're evaluating. Then we call this external variable reference, and this is actually something from the craps table class. Which I think it's should be craps table. So we'll look for the init function. This will tell us how this gets set here. Yeah, scripting variable reference, this is the function that we call. And as you can see, we just do a switch on the variable name and just directly match on the variable name. There is no case detection, there's no white space trimming or anything like that. In fact, I already demonstrated what happens if I pass in extra white space. We don't do case detection either. If I say craps eval print die1 with a uppercase D, that won't work either. And I think that's fine because we do want those variables to be case sensitive. But it does indicate that when you can't find that variable, we get that error. So that's a good error, but the white space issue is not a good problem. We want to fix that. And so what is the solution? And if we just wanted to fix the white space issue, we could just add a trim here, easy. But what we really want to do is to get this statement working here to be able to do simple arithmetic. And so we need an actual tokenizer and parser to separate out the variables from the operators, from white space, and figure out what to do with all that. And so that's kind of where we are today, is to start that tokenizer parser and start building that up. And for those who have watched previous streams for a while, you will note that I did have, I think, one stream where I did work on a tokenizer parser interpreter for a custom language. And I'm going to kind of replicate some of the work there. I think that work was done in Java, maybe? Let's just go bring that up real fast to remind people of what that project looked like. And as always, all my code is on GitHub, so you go to github.com/CutePixel, you see all my repositories. The one I'm working on today is Twitch Crapspot, but Noble Sturman is the one for custom language. And yeah, palm.xml, that is a Java structure, so that's definitely built in Java, versus, of course, right now, I am in Node.js developing JavaScript. So the process I did before was to basically start, come up with a simple state machine and start tokenizing the expression one character at a time. You basically look at the first character in the string and go, what is this? Is this a number? Is this a letter? Is this an operator? And just kind of start building up tokens to process that. And so probably the simplest thing to do is just start with a simple loop here to evaluate one character at a time and just see what that looks like and just slowly build that up. So we have our expression. Let's see, what can we do? I just need to remind myself how to parse out strings in JavaScript here. Do I need to do like a substring, or could we do like a char at type thing? I'm more familiar with Java. From char code, from code point. That's to build a string. I want to basically take char at. This might be the one I want here. Yeah, let's just see what this does. I like to just build up very basic things and expand on it. So let's say for var I is equal to 0, I is less than expression dot, is it size? I can never remember, is it size or length, or it looks like length. Now let's just do this dot. I hate this editor sometimes. This debug message. We said .char at, I think is what it was. So this will do nothing other than step through the string, the expression character by character, and we'll just see what that looks like. Let's go bounce the bot here and give that a try. This is a craps eval print die1 undefined. All right, so I missed something there. sure what I've missed. String prototype charet. Oh, actually I need to give it a username here. I forgot about the function I'm calling. Yeah, try that one more time. Craps. Eval print die1. Cool. So there we go. So DIE1, we have our character evaluation there. So yeah, let's just start building our simple state machine. We'll say var state is equal to 0. Now let's just start documenting what our states are. We'll say 0 is our start state. Or, I don't know, I might change my mind about this down the road, but because we might have like a not in the middle of anything state. But we'll call it start states for now and see where we go from there. And we might have to change this loop because I remember having to do like a pushback setup where we inspect the first character, and if it's what we want, we absorb it into whatever it is we're processing. If it's not what we want, we put it back and start over and try again. So we might have, we'll experiment with this. I could do it with a for loop, so we'll start with that, but I might need to change that down the road here. So what are our options? If it's a space, we probably just want to absorb it. Now let's start with a switch based on state to decide where we go from here. Case expression, blah, blah, blah. And let's see, if we have a default case here, probably we want just a quick error message. Unsupported state. And in cases like this, we just want to do a return. I think null is what we indicate for an error. So we should never get here, but if we have a developer issue and I use a state that doesn't get recognized or isn't supported, I will at least see the message here. And let's see, in case of this, your case is 0. Actually, no, switch is going to be pretty crappy because we're going to have lots of complex statements. So I think what I want to do is say, instead, let's do an if. So if state is equal to 0, let's do some stuff. Else, and here we'll put in our default. Because the statements are going to be too complex. Oh, come on. Too complex to really do conveniently in a switch statement. So we'll start with if-else block. Oops, and this isn't actually where it goes. That goes there. Alright, so what are our options? We could encounter white space, So if, in fact, let's do this. Let's say var character is equal to expression. Let's just grab this guy. Just so I don't have to do this over and over and over again here. Update this commented out code as well. So if character is equal to white space, or a space, what do we want to do? Probably just want to continue with the next character and pretend this didn't happen. So continue. The other thing we could have it match would be the start of an identifier. So that would be, A through Z, either uppercase or lowercase. I wonder if JavaScript lets me do character comparisons like Java does, because I can know Java characters are just a integer. So what does char@ return? It returns a string representing the character at the specified index. Here we have getting whole characters. If we have Unicode issues, which I'll probably have to ignore for the moment, but at some point I might need to deal with Unicode extra wide characters. I'm not sure if Twitch chat allows that or not, so it may not be an issue. Oh, there's a lot of junk here. Well, this is all nice, but what I really want is to be able to do JavaScript character comparison. Of course, we're getting all the comparison operators here, but we're not talking about can we compare characters. Let's see, to see whether a string is greater than another, JavaScript uses the so-called dictionary or lexicographical order. Not a real dictionary, but Unicode order. So it looks like I could do something like, oops, like this. If character is greater than or equal to a, let's do lowercase a, and if it's less than or equal to z, lowercase z, or this is the whole thing with capitals here, capital A, capital Z. In fact, let's do these on separate lines here just so they line up properly. So an identifier can start with a letter. Some languages, like I think Java, will let you start with an underscore. Do we want to start with underscore? None of our system variables start with an underscore. But why not? Let's allow an underscore as well. Or, oops. Say character is equal to underscore. Then let's add parentheses around this whole statement. So let's just say skip white space, or ignore white space. Look for the start of an identifier. And so in cases like this, what we could do is say, let's process the identifier somewhere else. Well, let's see. We need to start tracking the identifier, so we could say u of r identifier is equal to the empty string. And here, since we're starting a new identifier, we can say identifier is equal to character, so we'll start it with the character. And we'll say state is equal to 1. And let us put that character back into the for loop, so we'll... Actually, no, it doesn't matter because we've already added it to the identifier, so we're fine. We're done here. And then what else do we have? If, let's see, well, we can continue here. And if we don't recognize anything at this point, we could simply say unrecognized character. So let's do unrecognized state. So if we get this far, if we haven't hit a continue yet, then we have an unrecognized character. Alright, so I can test the basics of this. It's obviously going to crash right now because, or not crash, but it'll error out because we don't handle state 1. But we can at least test and see if it supports, if it recognizes that we're beginning an identifier at this point. And so let's just give that a try and see what it does. Let's just say craps eval print die1. Evaluate expression, die1, I recognize state 1. So perfect, so it recognized the D, started an identifier, switched to that new state, and then failed to continue because that state is not recognized. So let's add support for that state. Actually, before we move on, let's just test a few other things here. In fact, what I think I want to do is let's add this debugging back so we can see what it's doing. In fact, it might be best if we said index colon I and then send out the character so we can begin to see what is going on here. In fact, what we could do entirely is add in a state output as well, just so we can track all of the process. So we have state, index, and character. We can use that to track the parsing progress here. So we'll try the same thing as before. Grab eval, print, die1. Looks like I screwed up something in that debugging statement. I missed a plus sign after the I, it looks like. Anywhere else? State plus index plus I plus character plus character. That looks good. Yeah, so we have state 0, index 0, character D, state 1, index 1, character I, unrecognized state 1. Perfect. So that is what we would expect. Then let's test some other basic stuff here, like let's test space handling. So say craps eval print space die1. We'll do a space at the end as well, why not? Yeah, so we have state 0, index 0, character. Probably want to do some sort of brackets around that or something so we can actually see the white spaces. State 0, index 1, character D, index 2, character I recognize state 1. So that does work. Let's go ahead and add a simple bracket or something around these. I think I usually do like square brackets. Just so it's much easier to see those spaces. So craps eval print space die 1. Perfect. Let's see. Any other testing we could do? I think that's just, we just have the space handling and the start of identifier handling. So that's all we can test so far. So let's move on. Let's add support for state 1. And let's document what state 1 means here. Let's see, processing identifier. Alright, so else if state is 1, we'll do something. So what are our options for state 1? Well, as before, we can look at white space. So white space signals the end of an identifier. So if character is equal to space, let's see, we don't have anything to do with this yet, but we can log it. We can do a debug message. And say found identifier. And let's go ahead and continue. Otherwise, we want to look for something that might continue the identifier. Look for the next character of the identifier. So we've already started with a letter, either A to Z, lowercase, uppercase A to Z. And we also allow an underscore. And I think the only thing we want to add next would be numbers. So let's go ahead and add support for numbers here. So if character is greater than or equal to 0, and it's less than or equal to 9, I think that also counts. And if that is the case, we could say identifier plus equals character. and continue. Otherwise, we have an unrecognized character at this point. So let's do this here as well. So if we do anything that is not a letter, a number, or an underscore, it's still an unrecognized character at this point. So we'll continue to throw that here. As in, when we found the identifier, what we should also do is reset the state to 0. And I think that'll be enough to identify identifiers. So let's go give that a try and see what that does. So as before, say craps eval print die1. We'll put that in, we'll give spaces there. Alright, so found identifier die1. We still have unable to find variable because I have all the other code that's still around that doesn't support the spaces. We're not actually hooking up the parser to anything just yet. If I do this, it should still work. It should find the identifier and still give a proper evaluation. Now if I put multiple expressions or multiple variables in here like die1, die2, we should find both identifiers. I found identifier die1. Something's broken. Why did it not? Oh, right. So this is another issue, which we get to the end of the string, we get to the end of the expression, and we're still in this processing phase. We're still in the state of processing an identifier. So we have a couple of choices here. We can check our state at the very end, and if we're in the middle of processing an identifier, we can simply return the identifier. Or we can append a space at the end of the expression to basically force it to go that last extra step here. Hey, Pixel Grief, how is it going? Welcome back to the stream. Well, I think in the spirit of the simplest thing that could possibly work, the thing that'll have me write the least amount of code, we're going to add a white space to the end of the expression. So let's say expression is equal to expression. Actually, this is to plus equals white space. That'll, of course, break everything else, but allow my tokenizer to actually pull out the last element of that expression. So let's give that a try and see what that does. Yeah, so craps eval print die1 space die2. Looks like I have a bug. Not sure where that bug is, but something is broken. Oh, I put this in the wrong spot. Let's put that at the top of our function here rather than in the for loop. Craps eval print die1 space die2. Perfect. Yeah, so the only thing we're adding is this extra white space here at the very end just to force us to get this die2 out. There might be a better way of doing that, but I'll stick with the simple approach for right now until I see a reason to switch it. All right, so what else is going on here? Well, we could test different possible error states here, like let's just try a very simple. We know what we want to do is to be able to plus these together. So let's say craps eval print die1 plus die2. Unrecognized character plus. Cool. That does seem to be what we would expect there. Just trying to think through what's next. What we're going to want is to come up with a series of tokens. We'll probably want to make a tokenize function here at some point, but we'll leave it all in line for now. But I'll want to refactor this at some point. Yeah, so let's document why we're doing this. Let's add a space to the end of the expression to make it easier to So this way we don't have to do any sort of kind of final state handling. We just have everything go based on space. And we'll continue using this for as long as we can. And so yeah, I think what we want to do is say var tokens is equal to empty array. And then when we get an identifier, let's push that. We'll say tokens dot push, I think is the correct phrase. Let me just see if push is correct. Yeah, push is correct. Perfect. So we want to push a something to our token list here. If I was in Java, I would probably build a class for an identifier token. JavaScript, I could as well, but I think it's going to be far easier in this case to push a kind of a complex type here. We'll give it a type identifier. And let's give it a name as identifier. So that way when somebody is going through the token list, they can go, okay, I got a token here. What's it type? Its type is identifier. That means it needs to have a name. Let's look at the name. That should give us what we need there. We could keep the debug message for now. I'll probably want to clean up some of this debugging. I've got a lot of debugging right now, and not all of that's going to be really relevant or useful in the future. So I think I'll leave it for now, but I'll clean it up before I commit, just to try to trim that down to what seems relevant. All right, so we push the token, the identifier token, to our tokens array. We could get to the very end. And just do a simple test. I don't know, I think I do want to move this to a different function at this point. So we have process command. Let's just do like a tokenize function. And we're still going to need a username, because if we have an error, we want to know who we're going to address that error to. We'll have expression here. Let's just see what we want to pull out here. finally, let's return tokens. All right, this is interesting. So we actually return null in these cases where we can't tokenize. And so that's good. So we're either going to get an array or we're going to get tokens out of this. I can say var tokens is equal to this dot tokenize. We're going to give it username and expression. See, if tokens is equal to null, now we know we have an issue. And able to tokenize. We've already printed out the expression, so we will just do that. In fact, let's just test this as is so far and see where that goes. Make sure that all works. Like something, I probably forgot a comma after my tokenize function. Yep. I've seen that error a few times. Yeah, so we have unrecognized character plus unable to tokenize, failed to evaluate expression. Actually, we could say failed to tokenize expression to keep it more in line with our other errors. There's our other error message. Where did that go? Ah, here it is. Failed to tokenize. And of course, what we should do with the invalid character messages is print out the character as well. Yeah, let's just do the same thing we did up here. So this way, if we have an unrecognized character, no matter where we are, we'll just process that. We'll process it the same way. Yes, I'll try the same thing again. Craps eval print die1 plus die2. Unrecognized character plus, failed to tokenize, failed to evaluate. You would say craps eval print plus. Should just fail right away. Just testing the different error there. Craps eval print 1, 2, 3. We will eventually want to support number literals, but for now we don't. Cool. So we've got some other errors to address here. Let's go back up to the evaluation function. And if tokens is empty, so if tokens dot is it length, size? I don't know, I need to always remind myself of how JavaScript handles array length. JavaScript array length. Yeah, so it's a length property, not a function. tokens.length is equal to 0. Then we can do the same thing here. It's a little different error message, but basically no tokens found in expression. So we just say no tokens found. So this way, if someone does something silly, like puts in a complete empty string, or nothing but space, we'll get an appropriate error for that as well. We'll say craps eval print empty expression, no tokens found. Or if it's just a white space, no tokens found. If instead it's space die1, that all works. Separate all these conditions here. Alright, now just to test the token processing, let's just print out all of our tokens and see what that looks like. So say for var I is equal to 0, I plus plus, I is less than tokens.length. Did I get those backwards? I might have gotten those backwards. Yeah, and the I++ needs to go to the end. Now let's just dump the tokens. I'll grab this guy. Now the page up, page down of this editor is not great sometimes. Alright, so we don't need state. Let's start with index. Let's just print out the token sub I. And see what that does for us here. I was hoping to do a little better than that for us here. Huh. Well, we could do a token to string helper to help us with this for the moment. Say token to string. Let's take in a token. And so we need to check to see if something's defined. Looks like I could just do a undefined check in an if statement, so let's just give that a try. So if token dot type is undefined, return undefined. If token dot type is equal to identifier, return otherwise return unidentified or undefined. There's a simple helper so we can print out some basic stuff here. So say this dot token to string of this guy. Let's make sure I've added a comma at the end of that. I think I did. Nope, I did not. I thought about it, but I didn't add it, so I'll add it now. And give that a try. Alright, so we have index 0 token identifier die 1, index 1 token identifier die 2. Looks good. All right, so what's next? We probably want to add in support for the plus sign, because that's the current target. Let's get rid of the completed stuff so we can start thinking through what we're working on here. So this is the target, is we want to be able to do some simple arithmetic and have this expression work. In fact, let's just do our very simple statement here that we can use for testing. Craps eval print die1 plus die2. This is what we want to have working. And I think this is what I have been testing. I haven't been doing the plus sign, but I've been doing the separate identifier. So now we want to do the plus sign. This won't work because we don't recognize the plus. I recognize character plus. But that gives us the target to start working towards now. So let's give that a try. So if we're in state 0 and we encounter a plus sign, then we know it is a plus sign. Look for operators. So if character is equal to the plus sign, let's see, we want to add a new identifier, or sorry, a new token. So let's push a new token. Tokens.push instead of identifier, this will be plus. We don't need a name on this one, so we're just going to go straight out plus here. And I think continue. We also need to address what to do in state 1 when we're in the middle of an identifier. Because right now, we only have space indicates the termination of an identifier. Otherwise, we have unrecognized character here as well. Now, what we could do is treat any unrecognized character as the end of an identifier. Which might work. It's simple. It might lead to some weird cases where somebody expects something to be in the supported character set for an identifier, but then it actually doesn't work and results in a weird error. Let's do it. Let's be simple. Let's just say, if you're looking at an identifier, either the next character is a continuation of that identifier or something else, and we don't know how to process it, and we assume that's the end of the identifier. We'll continue to do that until we have reason to believe otherwise. And that'll be simple and allow us to get past this without having to duplicate some of this code here. Because the only other option is I need to add another statement here if character is equal to space, or if it's equal to plus. And as I continue to add new operators, I need to add minus and subtract and divide and multiply and mod, and I have to basically maintain 2 or more lists of all the identifiers. If I have different types of tokens, like say, well, numbers, integers, and floating points would probably be a token I'll support at some point, and I'll have to always be adding, maintaining multiple copies of the lists of characters that are supported. So by doing this, we simply say, all right, either it's a continuation of the identifier or something else, and we don't know how to handle something else, we'll let something else deal with that. Otherwise, we assume we are done with the identifier. Let's grab all of this junk here. Oops, wrong spot. Though we don't need this error, we don't need this return, and we don't need this block here. I got a capital identifier, let's lowercase that. My code assist likes to capitalize certain things, apparently. So yeah, if we have a plus sign, we simply return a plus token. See, I don't think our token pretty printer handles pluses. Let's try it as is and see what it does here. Yeah, so token identifier die 1, token undefined, token identifier die 2. That's what I expected. Actually, what we could do at this point is we can handle all the complex types up above, then anything below this that's not a complex token type, we can simply return token.type. That might be easiest way to go there, simplify our logic. Of course, my clipboard has been destroyed, so let's rebuild my clipboard and paste in again. Yeah, so we have identifier die 1 plus identifier die 2. Looks perfect. Alright, so what's next? We have our list of tokens. We're able to tokenize identifiers and plus signs. but we don't have a parser that's able to deal with that just yet. So let's think through what to do to parse this. Yeah, so we have our tokens. If it's null, then we know we failed to tokenize. If the length is 0, we know we have no tokens in our expression. Otherwise, we need to find some way of parsing this. And so for a parser, I mean, if we have one token and it's not an operator, we basically want to return that token. Let's build a parser and start thinking through what we could do with that. Call this parse tokens. I think we'll keep the token null check here, but I think the token length check, I think we can move down to the parser. We'll start with that as our base case. Like I say, var results is equal to I already have a var result somewhere down below, I think. Yeah, var result. Let's call it parse result just so we have something different to work with. We'll call it parse result. We'll say this dot parse username comma tokens. Then if parse result is equal to null, fail to parse expression. But we're not really going to do parsing here, and we could. I mean, if I'm building a parser, I probably want to return some sort of syntax tree or something. Kind of just want to do evaluation. I don't really care about parsing, I just care about evaluation. So I think I've got to treat the list of tokens. Well, I'll see if I could do a combine parse and evaluate at the same time here. So let's call this eval result. And we'll say eval tokens. And we'll see if that makes sense. I might have to do a syntax tree for this if it's just too hard to do it, to do parsing and evaluate at the same time, but I think I can get away with it. We'll see though. So failed to tokenize expression, failed to evaluate tokens. Now let's just return null anyways, because we don't have anything else to do yet, just to see if this much works. Make sure I haven't screwed up any of the simple refactoring so far. We'll grab our standard test case. Eval tokens is not a function, right, so I forgot to update. Right, it's right here actually. Eval tokens. Eval tokens. Failed to evaluate tokens, failed to evaluate expression. Yeah, so we're not getting any error from those. If I was to do this, a craps eval print empty expression, say no tokens found, failed to evaluate tokens, failed to evaluate expression. Perfect. All right, so what are our base cases for evaluation? So we basically want to take something, take our tokens and return something we can process. And this is going to be called recursively, so whatever it returns, we're going to want it to be able to be processable by this guy as well. Well, let's just check if it's length 1. Start with length 1, and we can start working on our base cases here. So if it's length 1, basically the only thing we support right now that we could process would be an identifier. So let's try it. Let's say if tokens 0 dot type is equal to identifier, let's see, we have an example for this. Let's go grab our example. We have external variable reference. We'll just grab this guy. Yeah, so our result is null, unable to find variable, and return null. Otherwise, return result. Then at the very end here, we still have an error. Don't know how to handle multiple tokens yet. But if we give it a single identifier, it should be able to process that and return it. Let's see, if it's not an identifier, then we don't know what to do with that. So we need an else. And so we don't want expression here. We want our name is equal to token 0 dot name. Go var name, I guess. unable to evaluate. I'll do this dot, I think token to string is what I got. Token to string, tokens 0. So I think that's all the cases. So if the length is 0, we could play no tokens. If it's 1 and it's an identifier, we try to look up the variable. If we can't find it, we complain. Otherwise, we return our result. If it's not an identifier, we complain and say we don't know how to evaluate that and print out what that is. If we have multiple tokens, more than one token, we complain as well. Now, this is not quite what we need just yet, but it gives me enough to at least test the framework, so let's give that a try and see what we get. So we have identifier die1, identifier die2. Don't handle multiple tokens yet. Great, so now let's try a simple case, say craps eval print. Let's give it nothing. No tokens found, failed to evaluate tokens, failed to evaluate expression, excellent. Print. Give it die1. In fact, let's give it some spaces in there to see if that all works. Available to find variable die1. Okay, so let's see here. Found identifier. So this returns the results, but where does that go? Oh yeah, we have some stuff to get rid of here. Let's delete this. Let's move this up. And yeah, so we need to basically replace this block. In fact, we can drop this block. We can simply return eval result at this point. In fact, let's substitute this with result since we don't need the rename anymore. And let's give that a try. So let's try craps, eval, print, empty expression. No tokens found, failed to evaluate tokens, failed to evaluate expression. Eval, print, die1. Found identifier, die1. We have our token, identifier die1, result 0, after expression, print 0, 0. All that all works. Let's add some spaces. Craps, eval, print, space die1 space. So I think what I want to update the pretty printer for tokens to include brackets around things. Not that it really matters, but maybe not. Let's just leave it. I'll probably get rid of most of this error handling or debugging before we're done here. So it does work. Let's try the more elaborate case. This should still fail because we don't have any processing handles multiple tokens. Don't know how to handle multiple tokens yet. Let's also try giving it a crappy variable name. So craps eval print broken. Yeah, so we can see we have like 3 layers of errors here. Can't find the variable, can't evaluate the tokens, can't evaluate the expression, can't evaluate the expression. So lots of layers of error handling. I've been debating at some point, do I want to throw in exceptions so that I can get rid of some of these layers of error handling. For right now, what I'm doing seems to be okay. But definitely error handling might be or exception handling might be a better way to go with some of this. Alright, so we have a couple of problems here. We still don't know how to handle multiple tokens, so we obviously need that to handle the plus sign. Just trying to think through what's next. We also don't have typing on this evaluation here. Yeah, we call this external variable reference. Let's go look up what that does here. We just return the raw result. So die1 returns numbers. Die totals number, point is number, max payout is number. Firebyte allowed, that returns a boolean. Balance is a number. And in fact, these are really, I think JavaScript doesn't really have the distinction between integers and floating points, so everything is considered a floating point. But internally, we could track the difference between integers and floating points in our own scripting language here. And I think I am going to want to do that, because for things like betting, we want to bet integer amounts. But we don't have any type information on this. We simply return the raw values. And so right now it's not a problem because we simply process out that raw value, dump it into our print statement. If we go back to where this is actually used, I'll show you what that looks like. Yeah, we replace the expression with the result. But internally, when we're processing expressions and we're doing plus, minus, divide, multiply, we want to be sure that we're working on compatible types. If you're doing a plus operation, we want to be sure we're adding integer for integer, floating point for floating point, and not trying to add, say, a string to a float or something. And so what I think I want to do is start adding in these more complex types here. So we could say you return, I think, type colon integer. Value is that. I'll do that for die2. Die total, and point. Let's go line these up now that we have something to line up. Max payout, that's going to be a float. Let's see, firebet allowed. This is going to be a boolean. Oops, I need to do that. I think I might have switched things up here. Let's just take a step back. There, that's better. And this value is pretty complex. We're just beyond the limits of what we want to support here. We could do this to simplify it. Var fire bet allowed is equal to that. And that'll work. And balance. Let's see. This looks like it's a float as well. Alright, so we've added these new types of tokens, for lack of a better word. They're going to be treated like tokens. And so we have integer, float, boolean. Let's go ahead and add those to our token to string. So if it is integer, return integer token.value and float and boolean. So now, when we evaluate tokens, we're going to get one of these complex types, and it's probably going to break things. So let's see how that breaks for the moment, and then go fix it. I'm a big fan of breaking things and fixing them. So let's try craps eval print. So we'll give it something that's good, but should break things. After expression evaluation, print object object. We're printing object object, so we really want to print out the value of die1, and so we need to convert that complex type into the raw value. That's what I was expecting there. Let's see, we could assume that we're always going to return a raw type and just do results.value. I'm debating if I also want to check to see if we ever get a type back that is not what we would expect. It shouldn't, because the evaluation engine should always return either null to indicate failure or a raw value. So I think I'm going to maintain that assumption and just always grab value out of it. So let's go see if that works. So craps eval print die1. Great, so that does indeed work. All right, so what is next? Don't know how to handle multiple tokens yet. So if we have multiple tokens, we're basically like only for right now we're only going to support plus operations. So again, the only real target is this case right here. So die1 plus die2, and so we can assume that the expression we're evaluating is going to be along those lines, and anything that isn't that will just fail. And so let's see here. We can well, like I'm trying to decide. So we basically the process is going to be you'll look for the operator. The operator should be the second token in the array. If it's not, we can fail and say, oh, we don't know how to process this weird token. Don't know how to deal with that. If we do find a plus sign, then we basically evaluate the left side and the right side, then add them together and return that result. And of course, we want to handle more complex cases. If we do something like this, sounds like my music died. Let me go reboot my music. If we have a more complex case where we have 4 operations in a row or 3 operations in a row, we probably want to, we're eventually going to have operator ordering to deal with, which I'm ignoring for the moment. That's one of the benefits of starting with the plus sign alone, is we don't have operator order to worry about just yet, but eventually we'll have to do a more elaborate processing or more elaborate parsing to make sure the operator ordering is correct. But for now, we could do die1 plus die2, then take that result and add die1, take that result, add die2. And so basically for this, we'd take this guy and then add this together as kind of the first operation. What I'm trying to decide is what happens if we do something like this, where we have die1 and a plus, but nothing behind it. Once again, for this, we evaluate the left side as die1, we evaluate the right side, well, there's nothing there. Now, we already handle the base case of no tokens, and so I could just split the array into 2 parts and pass in no tokens and let's handle. So I think I'll do that. I think I'll just be dumb about that and say, hey, I don't know. You told me to add nothing together. All right, so what's this if of? If token's length is 1. handle plus operator, maybe. All right, so we know tokens length is 2 or greater. So we basically want to go if tokens 1 dot type is equals to plus. Otherwise, you could say expected operator that got and then how do we split arrays? Does JavaScript have like an array split option? We have array from. Oh, it's a copy, a shallow copied. I don't want a shallowed copied unless I can give it like a sub array or an index to go through. It doesn't look like it. Let's see, array of, array is array, array of. No, concat, copy within. Shallow copy is part of an array to another location without modifying its length. No. Entries, every fill. Join do? No, not join. Let's see, reduce right function against an accumulator on each value of the array. Not quite. Reverse shift slice, maybe? Aha! This is probably what I want. Slice returns a shallow copy of a portion of the array into a new array object selected from begin to end not included. The original array will not be modified. It seems like that's what I want. Let's see if there's anything else that applies here. Sum, no. Sort, no. Splice. Changes the contents by removing or replacing. No. To locale, to source, to string, unshift. No. I think, is it slice? Slice is what we want here. Again, an end. If end is not specified, what does that mean? If end is omitted, slice extracts to the end of the sequence. Okay. So I think we could say var left tokens is equal to tokens.slice, or is it splice? Slice. I'm going to start at 0 and just get that first one. Var right tokens is equal to tokens.slice. Let's see, does it start there? I think we want to go to 2 and get the rest. Let's see what happens if begin is greater than the length of the sequence and empty array is returned. Okay, yeah, so that'll be great. Let's see, you could probably just put put this all together, we could say var left value is equal to this dot the eval tokens, I think. Username. I'll just give it the tokens to slice here. R value, or the right value. Yeah, so I don't think we need these any longer. Let's see, if result is null, so if left value is null, unable to evaluate left value. If right value is null, unable to evaluate right value. Let's see that. I think the only thing we want to address right now is floating points, or actually integers. So let's say if left value dot type is not equal to right value dot type, unable to add put that in brackets. Left value type plus brackets again and more brackets plus right value type and more brackets. So if we get this far, then we know we're the same type. So now if left value type is not equal to integer, or if it's not equal to float, and able to add, just give it the 1 there. Otherwise, return for type is going to be left value dot type. Value is left value plus right value. Actually, we could probably just do, think about some debugging statements here. So let's say var result is equal to that. Value is result. Say this dot debug. Damn it. Debug message. Give it username. And we can say adding left value dot type, or left. Let's do token to string. Left value. And let's do this before we do the error handling. Alright, so we're adding these two values. If the types are not the same, we complain. If they're not integer or float, we complain. Otherwise, we add them. Let's print out the result as well. Let's do debug message. Say result. Token to string on result. All right, we need to fix this here. This needs to be this full block. Return result. I'm wondering if we do want to do any sort of floor or anything to ensure that if these two values are indeed integers, or the type is supposed to be an integer, that we for this. I think for the moment I'm going to assume that if the two types we're given are indeed integers, they're specified as integer, then we're going to assume that the values are indeed integers and not have any floating point components. Since we're just adding, there shouldn't be any floating point issues. When we start looking at division, we'll have to add a floor or a round or something. We'll have to figure out what to do with division. But for addition, I think this is fine. Yes, then we do know how to handle multiple tokens now, so I think we're ready to give this a try. Okay, I screwed up something here. Let's take a look. This is line 264. Looks like one of my debugging statements is missing a plus sign towards the end. There we go. Alright, let's try some basic cases here. So craps, eval, print. Let's try the empty case. Failed to evaluate tokens, no tokens found, all looks good. Let's do a simple expression. Result object. We have a case here that's not so great. So let's fix that. I think that is where we do the replace. Where is that result coming from? So we have a val expression. Alright, here we go. Let's do main.token to string of result. Main is not defined. Oh, it's not main, it's this. I keep thinking main for whatever reason. I was working on some Java earlier and was used to like main classes and main methods, and apparently my mind is still on Java. Grab cval print. Let's try empty string. Die1. Result is integer, colon 0 after expression evaluation, print 0. Let's try die1 plus. That's interesting. Why is this not doing anything? Tokens.length is 1. Well, it shouldn't be. It should be 2. We'll go down to here. If tokens type is plus, we got left value, right value. Username. Starting evaluation of plus. Just to make sure we're actually getting here. No, we're not even getting that far. Why not? Oh, you know what? It just occurred to me, we have a bug in our tokenizer. We didn't handle the pushback component here. Yeah, so what we used to do is when we used to just check for white space, and if we caught white space, we'd push the identifier, we'd put out the debug message, we'd reset our state, and move on, and we just absorb the white space. Now, since we do this for any character, what we need to do is go back I minus minus. So process this character again with the new state. Because what's happening is we're absorbing the plus sign, but we're not actually doing anything with this. So that should fix that. Let's give this a try. So craps eval print die1 plus with nothing. Start an evaluation of plus. The tokens found, unable to evaluate right value, unable to evaluate tokens. Now say craps eval print die1 space die2 with no plus. Expected operator, but got identifier colon die2. I think what I want to do with all these guys is put square brackets. I've been doing square brackets for a lot of these. This will just allow it to be kind of universal, and I won't have to worry about having to do it everywhere. Like I've been doing it here, so let's drop this and this guy. In fact, this might make it small enough. Not quite. But if I do this, it'll work. Just barely. I don't like that. Yeah, I hate line wrapping stuff. We'll go with that as the least bad choice for the moment. Continuing on, let's look for other occurrences where we do this. Yeah, unable to add. Well, here I have types. Maybe we'll just drop the brackets off this guy. Use the brackets for the actual types, or the actual tokens. Here we have the token. We can drop that there. Yeah, let's give that a try. So craps. Eval print die1, die2. Expected operator, but got identifier die2, unable to evaluate tokens, unable to evaluate expression. Don't know why we're not seeing the beginning to evaluate the plus. What happened to that message? Oh, right, because we don't have a plus yet. Yeah, we're probably going to need some more context for some of these errors, but for now it's okay. I'll need to do a pretty thorough error handling debugging pass to just make sure that all the errors and debugging statements make sense. For right now, I don't think I'm going to bother. Alright, so craps eval print die1 plus. We should get the start evaluation of plus, no tokens found, unable to evaluate right value, unable to evaluate tokens, blah blah blah. Perfect. And we can say craps eval let's give it two incompatible types, like say die1 plus balance. So add an integer 0 and float 9480, unable to add integer and float. Perfect. Let's get a roll going here. Craps roll, just so we have a roll to play with. I'm able to add an integer and float. Let's add 2 floats. Actually, floats work. Let's add 2 booleans. So craps eval, print. And what does that look like? I think that's firebed allowed. That plus that should be 2 booleans. And able to add boolean. All right, let's drop the brackets around that. And able to add boolean types, and able to add those and those types. And we'll keep that the same. We'll do the values. Say unable to add values. Cool. And finally, let's go to our basic case. Craps eval die 1 die 1. Let's say craps roll 1 2, just so we have a roll going here. Unable to add integer values. Oh, that's interesting. That should be able to work. Let's see why that's not happening. So if left value type is, and if it's not equal integer and it's not, or let's see, we could say if it equals integer or if it equals float. That's probably the better way to go. That's a little more clear in terms of what we're looking for. Process all of this junk again here. Unable to add integer values. Oh, come on, I just fixed that. Why not? Oh, this is the error case. Let's see if it's... If it's not equal to integer, I was correct the first time, and it's not equal to float. That's probably the correction that we need there. Oops, I meant to do a 1-2 roll, but I guess we'll do a random roll. That'll work. Okay, so our plus procedure is broken. Let's see here. Ah, yes. We need left value dot value plus right value dot value. This time with feeling. All right, so we have start evaluation of plus, adding integer 1 and integer 2, result integer 3, so we have the results being returned multiple times because we do the result here. Do handling plus. Then we could say plus result. Where else do we say result colon? Evaluation result. And where else? That's it. Definitely need to address some of these error messages here. All right, so craps roll 1, 2. All right, evaluate expression die1 plus die2. Find identifier die1, die2. All right, so add in integer 1 and 2 plus result is 3. Evaluation result is 3. After expression evaluation, print 3. Perfect. So let's try a more complex case and see what happens here. Yeah, so we have recursive handling of plus. So handling 1 and 2 plus result is 3. Add in integer 2 and integer 3. Plus result is integer 5. Adding integer 1 and integer 5 plus result is 6. Yeah, the basics seem to be working, so let's take a second to think through our debugging messages here and see if we can either get rid of some stuff or clean up some stuff here. Like the tokenizer seems to be working. I don't think we need to worry too hard about the tokenizer right now. So I think we can clean up most of that. Like this. I don't think that matters. Found identifier, I don't think we care. Eval statement. There's got to be an eval expression with some debugging I'm looking for here. Yeah, so we probably don't need to print out the array of tokens at this point. We could conceivably do, let me get this back. We could conceivably print out the list of tokens when we evaluate tokens. Is a var token message is equal to tokens colon you say if I is equal to 0, then we can say token message plus equals, actually if it's not equal to 0, let's add a comma. Then in every case, we'll add a space. Plus that. Sounds like my music died again. Let's go take a look. Nope, it's back. It just went quiet. Evaluating tokens. No tokens found. And able to evaluate. Handle plus, handling plus. I think that works for the moment. Let's see what this looks like, what these changes we've made look like here. So craps roll 1, 2, craps eval, print. Let's just try some basic cases here. Evaluate expression, blank, evaluating tokens, blank, no tokens found. The evaluating expression. Evaluating compound statement. I don't know, I probably want to put string wrappers around these or something so we can at least see when there's an empty statement. Evaluating expression, which was another empty one. Actually, wait, I probably don't want to do all of these statements. Yeah, we don't want to do those. Because I think those already need to be Can those be blank? What happens if they're just blank? So craps eval nothing. No command specified. All right, so we do have the possible case there. Craps eval foo space. Of course, Twitch probably gets rid of the extra space. I don't know, I think I'll leave that alone. I'll leave that alone. Evaluating expression. Probably fine with that. Evaluating tokens, and here we have the list of tokens. I don't know, I could drive myself crazy trying to perfect this, and it doesn't really matter all that much. So craps eval print empty expression. No tokens found, failed to evaluate tokens, evaluate expression. Let's give it some garbage that we can't evaluate. And we'll find variable foo, failed to evaluate tokens, failed to evaluate expression. Perfect. Let's try plus plus plus. Why are these not being wrapped inside square brackets? Let's evaluate why that's not happening. I think there's a token 2 string that might not be working properly here. Oh yeah, so we have the return type. What we need to do is return bracket plus type plus bracket. Craps eval print plus plus plus. Evaluate tokens plus plus plus, handling plus, evaluate tokens plus, unable to evaluate plus, unable to evaluate left value. Let's try craps eval print die1 plus plus. Evaluating tokens plus. Yeah, what we really want for some of these errors is position information. So you can see what character or range of characters is causing the problem and perhaps even print out the range of characters. That's a bunch of work though. And again, I think I'll probably end up removing most of these debug messages. But I think for now, someone can see, okay, we're evaluating the tokens. We have an identifier and a plus and a plus. Evaluating tokens, identifier plus. Probably what we're missing here is identifier lookup debugging information. So we have like plus result, but we really need like an identifier lookup result or something. So let's just look at doing that here. we have var name. Variable lookup, and let's just do var name. Yeah, come on. Variable lookup result. So we're adding more information, but we'll see what this does for us here. So craps eval print die1 plus plus. Evaluated tokens identifier die1 variable lookup die1 variable lookup result integer 0. Evaluated tokens plus unable to evaluate plus enable evaluate right value. What might be nice is if we had some sort of indent. Let's try that. Let's build a debug indent here. Actually, let's just add an indent here. Indent, I think we could just say indent is equal to 0 if we don't specify it. JavaScript. Default parameter. All right. There's a var padding is equal to 0 for int I is equal to 0. I is less than indent. I plus plus. I'll say padding 0, no, empty string, thank you. Padding plus equals. Give it 4 spaces, I guess. We'll see if that works. And I'll do plus padding plus message. And the recursive component is going to be the tokenizer. Eval expression, no. Not the tokenizer, actually, the evaluation of tokens. Cool, so there's only 3 spots where we call eval tokens. So anywhere where we call debug message in here, we can now pass in indent. Yeah. I just hate this. username, message, indent. Now it all fit on one line. I think we're still inside evaluation. So I think the same thing for error messages. We could also apply indent here. Equal to 0. And I kind of want to refactor this. I don't have a good way of refactoring this right at the moment. So we'll leave it for now. I'll definitely want to rethink how to do my messaging. Let's find out where we do indent. Let's look for error message. All right, let's see what that does. That doesn't like something. Let's see here. Oh, not int I, it needs to be var I. I'm used to writing Java code. Let's go back to our test window here. We'll just try the same thing as before. Craps, eval, print, die, plus plus. Actually, die 1 plus plus. As here we have the top level indent, evaluating tokens, and we're handling plus. And so here we can see we're handling the left side. The variable lookup result integer 0. Well, it's odd that that is not coming back properly. Let's look up that. Oh, I put indent in the wrong spot. Just do a quick check and make sure we haven't done anything else weird with indent here. I think that's all correct, so I think it looks like it was just that one. So I'll try that one more time. Craps, eval, print, die 1 plus plus, handling plus. What I might want to do is do left side, right side, so we know what's happening here. Left side. I just do right value, left value. So it matches kind of more of our variables. Graps eval print die1 plus plus. In fact, what we might want to do is say indent is equal to indent plus 1. And let's decrease the padding by 2 in each case. Handling plus, so then we have the left value, the right value, so unable to evaluate plus. Where is that coming from? Evaluating tokens plus. There's an evaluation error that is not using the indent. So let's take a look. Unable to evaluate. Well, it is using indent, but it's not working. Why? Did I fail to pass it in properly? Let's take a look. So we're in right value, evaluating tokens. Yeah, so we have right value, and then we call eval tokens and pass in those tokens. We give it indent plus 1, so let's go to eval tokens. And we have debug message, that works. So that's what's printing out this line right here, so we know that much works. That's when we get down to the end. I guess it was closer to the top because we have the one case. We have one token, so, and it's not an identifier. And this is the error that is not working. Let's make sure that error message was updated properly. Oh, so I did all this work here, but I didn't actually use it in error message. So let's go ahead and add that. That's the issue. So let's try this one more time. So craps eval print die1 plus plus. I think that works. I don't know if I need to do that advanced indent. Let's drop that, see what that looks like here. So evaluate compound statement, evaluate single statement, evaluating expression, evaluating tokens, identifier die1 plus plus, handling plus left value, evaluate tokens of identifier die1, variable lookup die1, lookup result, integer 0. Right value, evaluating tokens plus, enable to evaluate plus. I don't even need to say what we're unable to evaluate because we just basically printed out the token we're evaluating. Just keep the messaging really simple there. I cannot type. Except we've lost our indent again. What the heck? Oh, because I got rid of the word indent. Yeah, so let's try craps eval print plus plus plus. Anyway, plus left value, evaluate tokens plus, and we'll evaluate. And we'll evaluate left value, evaluate tokens, expression, blah blah blah. Cool, let's do a quick roll, craps roll 1, 2, just to get some dice values going and try some of our test cases. So we have die 1 plus die 2. Alright, so handling plus left value is identifier die1, variable lookup die1, lookup result is integer 1. Right value, lookup die2, result is integer 2, adding integer 1 and integer 2. See, on these result lines, I'm thinking of dropping the result indicators here. Like for a plus result, I'm going to make that be a result and allow the indent to specify what that's a result of. Same with variable lookup. What else am I thinking of here? We probably want to start adding some indent to these things as well. So the compound statement I think we will keep as indent 0, but then we'll start adding indent below that. So eval statement, I think we could say indent is equal to 0. Well, we'll keep it here as well. We'll say who calls evaluate compound statement anyways. For eval statement, we'll just do indent plus 1. Eval statement. Just add indents to all of our messages here. And then I think we have a call to eval expression. We want to pass indent along here, indent plus 1. Then eval expression, we want to take in indent. So tokenize, I think we'll want to pass in indent plus 1. Here's another result line we can simplify, and we'll just allow the indent to handle that. Tokenize, we'll take indent here as well. We may not have, well, I guess we'll probably have some errors here. Yeah, of unrecognized characters. Unrecognized state. Eval tokens, and I think that should do it. So craps, eval, let's just try some basic errors here. Well, let's see, we have evaluated tokens is broken, so let's see, I bet when we call eval tokens, we don't call the correct, or we don't pass the right thing in any longer. Yeah, we need to pass in indent plus 1 there. Evaluate compound statement, print empty expression, evaluate single statement, print expression, empty expression, evaluate expression, evaluating tokens, no tokens found. What happens if I give it a token that doesn't recognize? Craps, eval, print. I give it a minus sign because I know it doesn't know how to deal with that. Evaluate expression minus. I recognize character minus. Failed to tokenize, failed to evaluate. Let's just try multiple compound or multiple statements in this compound statement here, all of them with failures. So print minus, let's do print percent. And print star is all those things. None of those things are recognized right now. All right, evaluate compound statement. Then we do the single statement. Evaluate expression, unrecognized character, double tokenize, fail to evaluate. Evaluate single statement, print. So you failed to evaluate expression. Where's that coming from? Yeah, I think this is part of the eval statement. Yeah, so I think that works. Let's try multiple expressions in these guys. Let's do a good one, followed by a bad one, and see what all that looks like. Compound statement, there's all of our stuff. Single statement, print die1 and a minus, evaluating expression die1. So variable lookup result, evaluation expression result. After expression evaluation, print 0 minus, evaluating expression minus, unrecognized character, failed to tokenize, failed to evaluate. Then we're moving on to the next statement. And this statement. I guess the second expression. I think that all works. It's a lot of messaging, and so we'll have to clean all that up at some point, or probably create debug flags so that all this doesn't get logged all the time. But for right now, it is certainly useful to verify that things are being processed correctly. Let's try a more complex example. Like we've got this guy here, we can test and see how this works. Let's get some dice results here. So perhaps roll 1, 2, just so we have some die values to play with. Yeah, so here we have some complexity and some depth here, because we have multiple layers of evaluation. So evaluate expression, die1 plus die2 plus die1 plus die2, evaluating tokens. Die1 plus, die2 plus, die1 plus, die2. Anyway, plus left value is die1, right value is this larger expression. Handling plus, left value is die2. Right value is this larger expression. And the plus again, left value is die1. Right value is die2. So result is 2, adding 1 and 2. Result is 3, adding 2 and 3. Result is 5, adding 1 and 5. Result is 6. Result is 6. After expression evaluation, print 6, and then finally we print 6. Then if we do run into an issue somewhere along this line, like if I type in die3, we took as integer die3, variable lookup die3, unable to find variable, unable to evaluate right, unable to evaluate right, unable to evaluate right, failed to evaluate, failed to evaluate. We got all useful error messages there. So cool, I'll just think it through what else to test or try with this. All we're really trying to do right now is to add in the simple expression evaluation of plus. So to get basically this statement working, which I'm pretty sure it's working right now, but let's go ahead and give that a try and make sure that our our fundamental test case does indeed work right now. And yeah, we have die 1, die 2, die total 3. And if we do a different die roll here, say craps roll 5, 6. Wait for that to resolve and try it again here. Cool, looks good. So I just want to look through my notes and see what I might want to consider next. You know, there are certainly different operators to consider. You know, we certainly have a divide operator to consider. Probably want to handle all the basic arithmetic. We've got plus, we'll want to add minus, multiply, divide, probably modulo for as the additional operator next to the division. Trying to think what I want to do next. Like, I have an idea for a program I want to write. The whole reason behind all of this is to start having scripting programs, and we want to have things like, you know, add condition, action. I think I actually have some examples of what this might look like. We have condition always. Bet hop, die 1, die 2. That's not even using any of the pluses. You know, kind of one of my thoughts is to look at, say, my current balance. It's like, you know, when my balance is greater than, you know, some value, you bet on the any 7 for max. And so for this, we would want to have, you know, my balance. I think we have a variable for this. Where is it? Balance. So it'd be when balance is greater than, could go 9,000 because the default or the typical starting balance is 10,000. So when my balance is greater than 9,000, bet any 7 max. But we have our format for creating a program. So what would this look like? So craps program create, we'll call this test. Craps program add to the test program. The condition will be balance greater than 9,000. And the action will be bet any 7 for max value. And then we want to do a where is it? Like a run? Yeah, craps program run. So this might be kind of my new. In fact, let's grab this as my example program here. So we'll create the program, create program test. We'll add a new line to it, and we have the condition is balance greater than 9,000, then bet any 7 for the max, and then run it. So to get this to go, my next step would be to add in processing of a greater than expression or greater than operator. And so maybe that'll be next. Let me look at my code and see if I'm ready for a commit here. I probably want to do some quick testing just to make sure I've hit all the edge cases I can think of. Because let me just look for all occurrences of error message and just make sure I've tested all of these guys here. So missing closing bracket. So if we have an expression without a closing bracket, let's go ahead and test that. So die1 without the closing bracket. Looks good. And see if we're missing the opening bracket, so we'll try the same thing, but without the opening bracket. Craps eval print die1 without the opening bracket. Fail to evaluate expression. So we get that for lots of different reasons. So craps eval print splat. Valid expression, no tokens found, failed to evaluate tokens, failed to evaluate expression. So that does work. Missing opening bracket. So when there's no opening bracket, assure there is no mismatch closing bracket. Ah, yeah, so we have the two cases here where we have we have a closing bracket but no, or sorry, a opening bracket but no closing, a closing bracket but no opening. We also have the case of craps eval print mismatched or reversed brackets where we do have the opening and the closing, they're just on the wrong side of each other. And there we go, that comes back as well. Failed to tokenize expression. So this is if we give it a token that it can't handle. Craps eval print, and minus is not handled yet. Failed to tokenize, failed to evaluate expression. Yeah, failed to tokenize expression was the one we got there. Let's see, fail to evaluate tokens. Okay, so this is where we tokenized properly, but then we couldn't actually parse or evaluate the set of tokens. So this would be if we have like a plus operator by itself. Let's go ahead and give this a try. So craps eval print, and a plus by itself we can't evaluate. Failed to evaluate tokens, failed to evaluate expression. The unrecognized character, I think we've already tested that because we did that to test tokenizing. Yeah, there it is there. Unrecognized state. Well, we can't really test this because this is just an internal thing. We can sort of test. We can fake it. We can break it and fix it. So craps eval print die1. Unrecognized state 1. And that'll do it. Go ahead and fix that. Make sure that works again. Craps eval print die1. Nice. What else? So we have unrecognized state. No tokens found. So this is if we give it an empty expression. So So craps eval print with an empty expression. Evaluate tokens, no tokens found. Excellent. Alright, so we have unable to find variable. So craps eval print die3 doesn't exist. Variable lookup die3, unable to find variable die3. We could probably simplify this function or this error because we have the variable lookup of what we're looking up right beforehand. So I think we can drop the variable name off that. Let's try that one more time. Craps eval print die3. Variable lookup die3, unable to find variable, unable to blah blah blah, all looks good. Unable to evaluate. Let's see, this is if we try to evaluate something that is nonsensical, like a plus sign by itself. So let's try that. So craps eval print plus sign by itself. It doesn't know how to evaluate that. Evaluating tokens plus, unable to evaluate because we don't know what to do with plus by itself. We need to add something to something else. Let's see, unable to evaluate left value. Yeah, so we have left and right values here. Let's go ahead and give this a try. So craps eval print plus plus plus.
Don't try this yourself. It's extremely dangerous.
So left value evaluate tokens plus, unable to evaluate, unable to evaluate left value. Debating if we need this error here. It's probably fine. It kind of mates with our pattern here where we have the underlying error. In this case, you're unable to evaluate a plus by itself, and then we add our error on top of it, unable to evaluate left value. So that's probably fine. The next one, obviously, is right value, so let's go ahead and give that a try as well. So craps eval print. In this case, we need a correct thing for the left side, so let's give it die1 and then plus plus, so we have a plus on the right side. So left value identifier die1, variable lookup die1 is 0, right value, unable to evaluate a plus, and we'll evaluate right value. So that looks good. Let's see, so we have adding A and B, and we have unable to add types. So this is if the two types are not the same. So we have like a float and an integer or something. So we could test this with, say, craps eval print die1 plus balance. This balance is a float. Adding integer 0 and float 9490. Now we'll add integer and float. Now we probably could do some implicit type conversion. For right now, I'm being very picky about these things, and I'm only going to allow like types to be added and force type conversion, explicit type conversion. Actually, right now I don't even support any type conversion whatsoever, so right now this just doesn't work. At some point when that becomes important, we'll decide what to do, whether we want to do implicit type conversion or explicit. For now, it gives me the ability to test errors like this. And finally, if we have two values that are the same type, but they're not integer or they're not float, then we can't add those either. Like we can't add booleans, for instance. And so let's go find a boolean we can add here. So craps eval print that plus that. We can't add true and true. So left value is true, right value is true. Adding true and true, I'm able to add boolean values. Oops. Let's see, continuing on. Expected operator, but got something else. So if we have two or more tokens that we're trying to evaluate, the second token must be, right now, the plus operator, but some sort of operator. So craps eval print die1 die1. So we can't just do two variable lookups in a row because that just doesn't mean anything. Value tokens, identifier die1 die1, expected operator, but got that. No command specified. We're kind of beyond this. We're outside of the evaluation stuff at this point. And so I think all the evaluation errors are working. Yeah, I can't think of anything else to test, so let's go do a quick diff and see where we're at here. And so we've touched two things. We've touched craps table and we've touched scripting. Craps table, we've basically modified all of our variable returns to return type information with a variable. So beforehand, we just returned the raw information, and now we say, right, the die values are integers, the die total is an integer, a pointer is an integer, your balance is a float, or sorry, max payout is a float. Firebit allowed is a boolean, balance is a float. Well, we've added indent information to some of this stuff. The bulk of the work, though, is we've added this tokenize function that now does tokenization of the expression and actually processes it one character at a time. So that's how we're able to look for plus signs and deal with white space and stuff like that. This is the tokenizer. I do a very simple state machine for this. We have two states right now. 0 is start state, where we're not processing anything. And then we iterate through the characters in the expression string, character by character. We get the character at the current index, and based on the state, we do certain things. Like if state is 0, we ignore white space. So if we encounter white space or a space character, we just continue. I don't handle anything like tabs or new lines, because this is Twitch chat, and I'm basically expecting everything is going to be all just pure spaces. If I find at some point that we get something besides pure spaces, I'll need to handle that, but I'm only aware of pure spaces right now. If there's not a space, then we look for the start of an identifier. If the character is a lowercase a to z or an uppercase a to z or an underscore, then we'll treat that as an identifier. We reset our identifier variable to be that first character. We set our state to 1 to indicate we're now processing an identifier, and continue with the next character. If it's not an identifier, we look to see if it's a plus sign. If it is, we add a new plus token and continue. Otherwise, we have our error message, unrecognized character. We don't know what to do with that character. If state is 1, we continue processing the identifier, try to see if we still have another character for the identifier. So we look for a to z, lowercase, a to z, uppercase. We add in numbers as possible values or possible characters for the identifier name. And we also still continue to include underscore. And as long as that remains true, we add that character to the identifier name and continue with the next character. Otherwise, we assume we are now done with the identifier. We push that to our tokens array. We reset our state to 0. And then we reset our iterator, not reset it, but we go back one character, so we process that character again. because, well, if this character is, say, white space, we're fine, we can ignore it, but if it's a plus sign, we need to be sure we process that plus sign. So we just reverse our iterator by 1, so we can go back and see what that one character is. And the general defensive coding, if we have a state we don't recognize, we just complain about that. Then we have our evaluation function. This basically takes an array of tokens and does some very basic evaluation with it. So I like to handle my base cases first, so we handle things like, well, if we have no tokens, we complain. We can't do any evaluation if we have no tokens to evaluate. If we have just one token, then it needs to be something that we can evaluate directly, and the only thing that we support now is an identifier. So we look to see if it is an identifier. If it is, we do the variable lookup. If we can't find it, we complain. Otherwise, we log the result. If it's not an identifier, we just complain unable to evaluate. So you can't evaluate like a plus sign by itself, for instance. If we have more than one token, then we're looking for operators. In this case, we only support the plus operator. So we look for plus, and we handle it. We evaluate the left side, we evaluate the right side. We add them together. Well, actually now we say we're going to add them together. We check types. I said I don't allow any implicit type conversion, so the two types have to be the same. The left value and the right value have to be the same type. And they have to be either an integer or a float. If all that's true, then we add them up, log the result, and return the result. And we added some pretty printing on tokens to help with debugging. And more support of some of these indents. It's cool. I think that's all good. The main thing here was to add initial support for expression parsing. The support for the plus operator. That's probably too long. We could say start. Start expression parsing logic. Starting with the plus operator. That's small enough to throw into a commit message. Alright, so that is committed. Let's see, I need to take just a quick break here. I need to have a quick snack and just walk around for a few minutes. So I'm going to set a 10-minute timer, and I'll be back to continue in about 10 minutes. All right, we're back. Thank you for your patience. Just needed to have a quick snack and walk around for a few minutes. Been streaming for about 3.5 hours, so just find it's good to take a quick break every once in a while. So do appreciate your patience. For those who are just stopping by, here is my upcoming stream schedule. I tend to stream every Sunday morning, United States Pacific time. It started at 9 a.m. I will also occasionally stream during the week on weekday afternoons and evenings when possible. However, my schedule doesn't always permit that, so it's tough to predict when that'll be. My next scheduled stream is 1 week from today, Sunday, July 14th at 9 a.m. But of course, we still have the work to do today, so let's go look at that once more. Alright, so the work I've done so far was to start my expression parsing logic, starting with the plus operator. So, let's just go review it real fast and see how that works. I can find the right window. I got too many dang windows open. So we can do basically a hand-evaluated expression. So Krabs eval print die1 plus die2, for instance, is what currently works. Of course, right now I don't have any die rolls, so let's do a quick roll so we can actually test that. And it handles white space and all that wonderful stuff, so that all works just fine. And we have lots of debugging information, so those who are struggling to write their programs will have information to see what's going on, and you'll hopefully be able to figure out what's going on. This is probably way more debugging information than we need, but while I'm developing, it certainly helps me at least, so I'm going to continue to have it the way it is. Alright, so I find what helps me when I'm working on a big project is to always try to work on whatever the next concrete goal is. And so I could say, well, hey, we've added plus, let's go add multiply, divide, minus, all these operators. But what I'm doing is I'm looking at a specific use case that I want to work towards. In this case, I want to write a program, a scripting program that basically says when my balance is greater than a certain amount, say 9,000 in this case, then place this bet, and just continue to place that bet as long as my balance is above that amount. And so here's some sample commands I could potentially use to make that happen. First create the program with no code in it, and then add the line of code to the program. So we have, the syntax here is, we're adding to the test program this condition, when balance is greater than 9,000, do this action. And then run the program. Now, none of this works. This doesn't do anything because I don't have the concept of programs added yet. Unrecognized command. What else? Program add test balance. Well, the program command still is not tested. Or not implemented. Yeah, so none of that will work. What we need right now is let's come up with a very simple case to kind of take the next immediate step here. We need to be able to have an evaluation of this statement. So let's just try that. So craps eval print. Let's see what this does here. This is obviously going to break because we don't have support for the greater than operator. But at least this gives us a test case we can start working with. Yeah, so as we expected, unrecognized character greater than. And so what would we do to make that happen? Now we have our eval tokens. Well, first we need a tokenizer. We need to actually tokenize the greater than operator. I probably don't need comments on these guys. They're going to be so simple. If character is equal to greater than, type is greater than. Well, that'll get us halfway there, right? Unrecognized character 9. Ah, right. So the other issue is we don't have integer literals or number literals. I don't know about you guys, this song is driving me crazy a little bit. I might have to switch the music here soon. Oh, let's see. I'm actually getting a phone call from my father here. I want to take this. I'm going to just step away for a couple minutes. I'll be back in just a little bit here. Sorry about that. I do turn my phone off during streams, but I do check when family members call just to make sure it's not something really critical. So apologize for that quick break. Alright, so where was I? So we have this statement here. We have kind of two issues. We can't... I mean, there's the greater than, and then there's also the numeric literal there. And I think the numeric literal might actually be the better place to start. So, craps, eval, print, 9,000. We'll start with this. See where that gets us. And we have a unrecognized character 9. In the meantime, let's go ahead and drop this guy. Actually, let's undo all the work we've done so far. We're back down to where we started. Yeah. And yeah, so let's think about a numeric literal. So if state is 0, look for the start of an identifier. We could say look for the start of a literal number. We could do the basics here and say if it's greater than or equal to 0, less than or equal to 9. We don't have case issues, and we don't have underscore. The only consideration is do we want to enforce that the first digit can't be a 0? Do we care about that? I don't think I'll care. My music stopped. I'll bounce that here. Because otherwise you get these weird errors like, oh, I can't recognize 0. Like, well, plus we might have 0 as a number by itself. So yeah, okay. So we definitely did start with 0. That'll work. Let's say state is 2 if we encounter a number. Let's document what this state is. Processing literal number. Let's see, rather we could use this whole variable here. Instead of calling it an identifier, we could say token. Oh, that was weird. Damn it. I want to do a search for identifier. Alright, that should do it. Alright, so we start at literal number, we set the token to be the character. The next thing is what to do if state is 2. It'll look a lot like if state is 1, so let's just copy paste this block. Also state is 2, look for the next character of the number. And it's still going to be 0 through 9. I think for the moment, I'm going to go with just integer literals, because that'll work for my current needs. Or will it? Let's see here. Now, because balance is going to be a float. Oh, I don't know. I'll continue doing it with an integer for now. We'll see how that goes. But I'm going to run into some hassles with type conversion, and I'm just not sure how much effort I want to put into that. Now look for the start of a literal integer. We'll make it so that case 2 or case 2 is literal integer. Let's see what else. So otherwise we're done. Let's see, look for the next character of the integer. Otherwise assume we're done with the integer. Type is integer. Value. We need to do a parse here. And I think we have an example code in our util class. No? I could swear I had a safe parse somewhere. Is it maybe here? Now we have a safe parse int. Then we could just do this. We've already kind of done the regular expression test where we've tokenized it already, so we know it is just pure numerics at this point. So parse int token with a radix of 10. And I think that'll work. Let's give that a try. So this is our test case. Actually, this is our test case, just a pure numeric literal. There's really no point to do it like this because you can always just write the 9000 directly without having to put it in an expression. But this will be a nice template or example for making sure that this is indeed working. Alright, so we have evaluating tokens, integer 9000, able to evaluate. Alright, so our evaluator doesn't know how to evaluate a pure integer, so let's go adjust that. Yeah, so we have handle single tokens. If it's an identifier, we do that. Else, if it is a number, integer, I guess. We can just return it. Let's give that a try. Yeah, evaluate expression, 9000, evaluate tokens, integer 9000, result, integer 9000. After expression evaluation, boom. Nice and easy. So I think that's it. We can try some basic stuff to see if some more complex stuff works here, but say, 10 plus 32 and see what that does. And we get the answer to life, the universe, and everything, 42. Excellent. So I think that's it for numeric or integer literals. Let's take a look. So we've added a new state to our state machine, processing literal integer. We reset token to the, actually we renamed identifier to token so we can use this for all of the tokens we're processing. Before I proceed, I should probably verify that your basic test case works here still, wherever that is. There, we'll grab this guy. Just to do a quick smoke test to make sure I haven't broken anything obvious. I still don't have any die rolls. Let's do a quick die roll, quick random roll there. And we get an 8. 3 and 5 is 8. Perfect. So we're looking at our diff here. Now look for the start of a literal integer. If it is greater than or equal to 0 and less than or equal to 9, then we know it is an integer. We reset our token to be that character. We set our state to 2 to indicate we're processing a integer literal, and continue. We renamed identifier to token. Rename that again here. See, the diff is a little bit weird. What we really added was else if state is equal to 2, look for the next character of the integer. So continue to be between or less than equal to, or greater than equal to 0, less than equal to 9. Add the character to the token and continue. Otherwise, as soon as we're done with the integer, we push that integer to our token list or token array, restart our state, and process the next character again with a new state. Frosty says, hey man, I'm ready, so I'm just going to lurk. So you can't hear me either. Well, hey, I do appreciate the raid, and welcome to the stream. And I guess that you can't hear me, I will talk to you then in chat. Sorry, well, to hear me because I can't type all my responses to chat, but glad you're able to hang out at least. All right, where was I? So if state is 2, we look for the next character. Oh, yeah, we got through all this. If we're done with the integer, we parse it and dump it into the token array. And then here we have the processing. We just handle a integer literal, and if that's what we're processing, we just return that right away. So it looks good. So add ability to parse literal integers. Or evaluate. It was a lot easier that time. Once I get the parsing logic in place, it becomes a lot easier to do some of this stuff here. Alright, so what's next? So we have this test case we're working on. Give us balance greater than 9,000. Let's go ahead and just test that real fast again. We know that that doesn't work, but it gives us kind of our test case starting scenario here. Which chat window am I looking for? That one. Yeah, so again, we don't recognize the greater than character. So let's go start adding support for greater than and see how far we get here. So we got our state machine. If state is 0, we're not in the middle of an identifier or a number. We ignore white space. We look for the start of identifier, look for the start of a literal integer, look for a plus sign. Let's go ahead and drop that comment. It seems pretty self-explanatory. Oops. And look for the greater than sign. Greater than. Of course, to do some of the multi-character operators like greater than equals, we'll need to think about that. But right now I just need greater than. We'll start with just this and see what happens. Let's go grab my test case again, bounce our bot, and give this a try. Expected operator, but got greater than. So we have greater than, and we know what to do with it. Or we know it's an operator, we just haven't coded up what to do with it. So let's go look at what to do with a greater than. Let's see, we're going to have kind of a typical pattern here. And we might be able to refactor some of this code down into a better function. So let's start thinking about that. As I was thinking, do we want to put in binary operator, but I think all the operators I'm looking at right now are going to be binary operators. I might have some non-binary operators, but we'll assume binary for now. And for binary, we could try like left tokens. Right tokens. There's also the operation. Try function plus operation. I'll take username, left value, right value. Now let's see what we got here. So we have that'd make more sense to just pass in the list of tokens at this point. And if we're going to do that, we probably don't even need to pass in the operation at that point, or the operator. At this one we could say return this dot handle. Or evaluate eval operator, username, tokens. What else do we need? Indent. Let's grab all this junk. Paste it into there. I could say, we'll do our typical handling here. If our result is equal to that, if result is equal to null, I don't know. I think I could just do the straight return. I don't think I need another layer of error handling on this one. You can say var operation type, var operation function. Let's do a switch based on this guy. Case plus operation type is equal to plus operation function is equal to this dot, is it handle plus? What do they call it? Function plus operation. Well, that's not what I wanted. Let's just go plus operation. Let's see, so if we can't find it, we should have a complaint here. Yeah. These lines are getting so long. I don't like the way that looks, but I can't think of a better way to handle that for the moment. And I suppose we could do this stuff. It seems like it might be just a little too much for a case or a switch statement. Because I'm going to put a whole lot of statements into here, so we'll just do it like this. I'll grab our else, keep it the way it was. Drop our all default stuff here. Alright, so now we don't need our if any longer. Let's go ahead and drop that. Let's drop our else. Let's unindent all this stuff here. Unindent. Operation type, handling operation type. left value, right value. And then this looks like it can go into the plus category. Even this feels like a lot more than I'd want, but well, let's see, we could try this guy. I already have it here. Let's see. We could do handling operator. Just make this nice and generic. Put this at the top. That way this error will make a little more sense. Left value, right value. We could do a plus. Plus operation type. Even this is getting too long here. Performing plus. We could say left. Say operation, colon type, comma left, comma right. There we go. We'll go with that. Yeah, it's too much. Let's see, so we have the type conversion issue. We've already said that plus we want to have explicit type conversion. Now if we say that for every single operation, we could simply continue to keep this logic here. The issue I'm about to run into is balance is going to be a float and 9,000 is an integer. And so if we're going to do that, then I also need to add in an explicit type conversion operation. And I'm not sure I want to do that. And so what I think I'm going to do is leave the type conversion up to the individual operations. So we're going to drop this guy and this guy. The result what we could do is say result is equal to, I think we have operation function, username, comma, left value, right value. Do some basic error handling here. If result is equal to null, unable to perform operation. That's not right value, it's result. Alright, so we don't need this. We still have our type checking. And then we have our result we could just return here. And I think that'll work. Let's give that a try. Syntax error, line 348. Looks like I missed a function call. Oh, a comma. Missed a comma. Alright, so let's try our basic case. In fact, I think I have some examples here. Let's try die1 plus die2. So let's get a basic roll, craps, roll 5, 6. Alright, evaluate expression, evaluating tokens. Handling operator, left value, right value, operation plus, left is that, right is that, result is 11. And lots of results, but that all looks good. Then what happens if we give it something that it cannot process? So eval, or craps eval, print. What can't it process? If it's a, we could do like 1, 1, 1. Oh, we'll do die 1, die 1. Skip the numeric literals just for the moment. Evaluating tokens, handling operator, expected operator, but got identifier die 1. Say, craps eval print 1, 2, 3. Expected operator, but got integer 2. Yeah, so that's if it's unable to perform the operation. Actually, no, we're not. We haven't tested that yet. We're basically testing this. So not even those. We're testing this case. Now let's test left value. If the left value is broken. So craps eval print plus plus plus. And I will evaluate left value. Craps eval print. Let's go 1 plus plus. So left value is that, right value is plus unable to evaluate. That looks good. See, unable to perform operations. So if we try to add floating, or if we add non-compatible types, so I think we could do, craps eval print balance is a float plus 5 is an integer. Indent is not defined. All right. This is line 335. All right, I need indent here as well, apparently. Craps eval print eval print balance plus 5. Huh. That's interesting. Alright, looks like the bot may have just not connected that one time, so we'll try it one more time. Craps eval print balance plus 5. This error message is not a function, right? So in this case, we have our binding issue again here. This dot operation dot bind this. That should satisfy that issue there. So craps eval print balance plus 5. Yes, here we have a float for 9519. An integer of 5, unable to add float an integer, unable to perform operation. Do I really need all of these different error levels here? And do we really need this guy? Let's think through some of these error messages because it feels like it's a little bit overly redundant in a lot of these cases. Like here we have this error, unable to perform operation, which follows on unable to add float an integer. That's really the case that we really care about. This is like, well, who cares? We know that we couldn't perform the operation because of that. So I think I'm okay just saying return that guy. Oh, we do have the results question. Which we could still do the checking and simply return null. Let's go look one level up here. Like that's what we do here. We don't even print out the result. We just return. Yeah, so let's go look for error messages. And we want to look for primary error messages, things that we're directly responsible for. And here it's a direct check. We're responsible for that check. Same here. Here we have failed to evaluate expression. Does it really matter? Because we're getting that, in this case, we're getting these 3 errors, actually 4 errors. You're unable to add float and integer, unable to perform, fail to evaluate, fail to evaluate. I think in this case, we could simply say return. There's really nothing to be done here, and we just assume that whoever returned null already generated whatever error makes the most sense. So let's continue to look for other cases. Missing opening bracket, yeah, that's still a primary error condition. Failed to tokenize expression. Yeah, so in this case, the tokenizer should have its own error messages whenever it returns null. Let's just go look up the tokenize function. Yeah, unrecognized character return null, so it has the primary error there. Unrecognized state return null, otherwise returns tokens. So yeah, I think that last change, or that last check, doesn't really matter. Then we have failed to evaluate tokens. This is when we call eval tokens, and again should have its own error handling. See, unrecognized character, that's a primary error. Unrecognized state, primary error. No tokens found, primary error. Unable to find variable, that is... well, I think that is a primary error because, well, this thing returns null. I don't think it actually prints an error when it can't find it. I think my thought for these things was to simply allow the scripting engine to handle the error handling. So yeah, so null in this case means can't find it, so we do need to do the check here and generate the error. So that makes sense. Unable to evaluate. Now this makes sense because we basically have no way of evaluating this item, so we do need to indicate that we can't evaluate it. We won't have kind of some deeper level error to tell us what happened. This is a primary error. This, unable to evaluate left value, and we say we're gonna do the left value, then we call eval, and it's gonna print its own error handling, so I think we can drop that. Same with this on right value. Oh, we need to return null, actually. Now we have the plus operation. Here we have primary error, primary error. That's a primary error, primary error. That's our function. Yeah, so I think that will help a lot of things. It's basically going to get rid of a lot of redundant errors. Let's go ahead and give this a try with our last test case. This is craps eval print balance plus 5. Yeah, unable to add float and integer, then we don't have all that other crap to say, Can't do this, can't do that, can't do this other thing. It doesn't really matter. Then let's look at this case as well, because I've had some concerns about just the multiple layers of printing results out. So we have the operation plus result integer 0 after expression evaluation. I guess that still makes sense. How about if it's just a pure variable lookup, creps eval print bounce. Variable lookup result. And let's look up all occurrences of result colon. So this is when we evaluate an expression. This is when we look up an identifier. And this is when we have the result of an add. Now, why do we have two results here, but not... I guess we do have the variable lookup result and then the operation result. Where is this coming from? Let's just start logging where these are coming from. So I think we got rid of all of those. Yeah, so we have 117, 254. In fact, let's do we'll do 0, 1, 2, 3. That'll work. That'll tell us which one we're looking for. Alright, so the first case was this one. Let's go see which results are resulting in this here. So we have result 1 and result 0. So result 0 is when we evaluate the expression. This is kind of the final result before we do anything. What is result 1? This is variable lookup. And I'm not seeing result 2 show up. Right, so result 2 is result 2 is the result of a plus, and I guess we Oh, interesting. We actually just return it. So we didn't even miss result 2. Let's not return and see what we get here. Say var result is equal to that. If result is equal to null, return null. Debug all that. Let's go see what that does. So we have result 2, result 0. What does result 0 do again? So this is whenever we evaluate an expression, this is after we call the eval tokens. And so the question is does eval tokens always generate a result? Because maybe I can just get rid of this bit here. So eval tokens, what does that guy do? Alright, so we debug, we print out what we're evaluating. We can simplify this a little bit here. I put in some code to try to get rid of extraneous space, but I don't think it really matters. So we log what we're evaluating. We log our errors. We handle single tokens if it's an identifier. We return the result if it's an integer. We simply return the integer. So this is the case where the level 0 return is going to be useful because we have this literal here. So I think what I'm going to do is let's expand on this. If tokens equals integer, let's do a debug. In this case, it's not result, it is tokens 0. Now we could say var results is equal to that. Oh, it doesn't even matter because if we're going to evaluate this, we basically... I don't think this matters. Let's test this real fast, but if we say craps eval print 5, we have evaluating tokens integer colon 5. We know that that's just going to be an integer, so do we even need to have a result for that? I don't think so. I think we can drop that. Yeah, so let's just return that. We don't need any of this. We could probably simplify things a little bit here. Var token is equal to that. I think that works. Here I think we can say value. Yeah, so let's look for 0. And yeah, I don't think we need this. And I think that means we could simply return this. We still have a 2 lying around somewhere. And I think that's still good. So we have the result of a variable lookup. We have the result of an operation, plus in this case. a literal, we don't return the value, and we don't return the value again after we've processed everything. So let's give this a test and see what things look like here. So let's try craps eval print literal 5. Now this is useful because we want to know what our command looks like after we do the substitution. So that makes sense. It makes a lot of sense, especially when we're going to have lots of stuff mixed in. We've got, like this is probably the biggest command I've got here. Oh, apparently I just placed a bet. I'm not really sure what happened there. Or you queried max payout maybe, I'm not sure. Yeah, so we could see how we slowly substitute all these things. So like, die 1 gets replaced with a 0, die 2 is 0, die total 0, 0.0, max payout is that, fire bet allowed is true, balance is that. I think that's fine to go through all those different things. I mean, if anything, we could possibly do, let's say, after expression eval. And we could possibly do this all at the very end after we've done all of the replacements. Let's try that. Now that simplifies things quite a bit. So we have evaluate expression die 1, tokens identifier lookup die 1, value is 0. I think that works. Alright, so we've gotten rid of we got rid of the overall return of, or print of results after expressions are evaluated, and we rely on the underlying functions to print out their own evaluations. So we do variable lookups are handled. Let's test basic arithmetic. Handling operator, left value is 0, right value is 0, operation plus left and right result is 0. I think that works. And then let's try integer literal. Craps eval print 5. Yeah, I think that works all right. Still debating what to do about some of these guys here. We have some extra spaces inside this guy. And so I'm tempted to just take a look and see what we're doing here. So we have, what are my statements? We have evaluating compound statement. evaluating compound. And is it ever possible that this is going to have extra white space attached to it? Let's go see who calls this guy. Who calls it, not it itself. We're giving it username and command data, so who calls eval command. Give it username and command data. Command data is command remainder. So, yeah, so get command remainder will remove any leading and trailing white space. So there's going to be no extraneous white space in here. Then we look at eval statement. We call that here, and this is after we do a statement.trim. So we know that there's not going to be any extraneous white space there. However, for expressions, we don't do any trims. So I think it might make sense to include the curly brackets for this. Because this will look a little bit better, I think. Yeah, I think that works. Evaluate expression 5 with the brackets, evaluating tokens, integer 5, after expression evaluation, print 5. I think that works. Alright, so I got pretty sidetracked here. What I was really looking at was being able to support this operation, to do the greater than operation, and I don't think we're there yet because I haven't actually added support for greater than yet. So let's go back and just make sure that still does not work. Yeah, so we're evaluating expression, evaluating tokens, handling operator, expected operator, but got greater than. Well, greater than is an operator, we just haven't built support for it yet. So let's go look up what to do for that. So I think we have our whole tokenize or eval tokens, eval operator. Yeah, so let's go ahead and add in greater than support here. Greater than operation, username, left value, right value, indent. So here we have the two types not being the same, and we're going to run into an issue right away here. And that balance is going to be a float, and we only support integer literals right now. And so I think I'm just going to make things more relaxed and say we'll allow loose type comparisons here. So at the moment, we really would only support integers and floats. And so if left value does not equal integer, let's see, if left value does not equal integer and left value doesn't equal float, well, first let's drop this. We don't need this at all. If left value is not an integer and left value is not a float, or right value is not an integer, and left value, or right value, is not a float. So left value must either be an integer or a float. Right value must be an integer or a float. See, unable to compare. Let's just grab this again. Unable to compare left value type and right value type values. Or just go like that. We'll keep it simple. Otherwise, we'll return. The type is going to be Boolean. Value is going to be left value dot value greater than right value dot value. And I think while we're making the type simplification for greater than, I think we can go back and adjust plus as well. And so I think I can drop this check, and in its place put something that looks like this. And able to add left and right types. Now the only downside is if any of these are a float, then we need to promote the whole thing to a float. We could say, var type is equal to, if left value dot type is equal to float, or if right value type is equal to float, if any of these are true, then type is going to be float, otherwise it'll be integer. Let's just pull out type. So automatic type conversion there if we need it. This, it doesn't matter, we're just going to return a Boolean every time. So let's give this a try. Let's come up with some simple cases here. So we have an integer case. Well, we have a couple of integer cases. We have die1, die2. That should all be integers. Let's go ahead and give that a try. Yeah, so all integers. Now let's try craps eval print. Let's see, balance is a float, and die1 is an integer. The result is float 9519. Excellent. Let's try craps eval. Let's see, we got the firebet lookup. Firebed allowed. Let's try a Boolean plus something, and we know this should fail. Firebed allowed plus die1, a true plus a 0. In JavaScript or some other looser language, this might make sense, but in my language, I'm going to say, no, this is not allowed. Able to add Boolean and integer, so that looks good to me. Just want to test this, make sure that the Firebed allowed works if we have a point. I haven't tested that lately. Say craps roll 2-2, just to get ourselves a point. Now Firebet allowed is false, and now we're trying to add false and 2, and that does not work. Excellent. Let's do a comparison. So the ultimate thing we're trying to do is to say balance greater than 9,000. Let's give this a try. Expected operator, but got greater than. So we still haven't called the new function I've created, so that's the next step. Let's go fix up the call to my new greater than operation function. That should do it. Oh, I need to actually fix that as well. Let's see, we might be able to say var operator token is equal to this, just so we can try to avoid having so many magic words here, magic numbers. Of course, that's not gonna, oh, it's just right at the edge. Don't have to wrap that just yet, but one more character would do it. Yeah, I think that works. Let's go ahead and give that a try. I'll just grab my test case one more time here. Yeah, so the error we had before was expected operator but got greater than. Here we have operation greater than. Left is float, right is integer. So 9519 is greater than that. Let's just test a couple different cases here. Let's see, 750, 9750. This should return false. Excellent. Yeah, 9750 is not greater than 9519. So I think that's looking pretty good. Make sure that some of these other basics still work here. Haven't changed a whole lot of stuff, but always good to just verify that I haven't broken anything too seriously. I think that's good. Let's go take a look at our Git status here and see where we're at. So I've cleaned up a lot of our error handling. We had a lot of redundant error messages, and I've gotten rid of a lot of those. I've also got rid of a lot of redundant results printouts, because it really makes no sense to say, hey, at every single level, here's my result, here's my result, here's my result. We just really need the deepest level to see the results, and everything else behind it, we'll just know that it's already been printed. So we've just gotten rid of a lot of these errors and result printouts. We moved this down below. We used to print this out on every single evaluation if we had multiple expressions in a single statement. Now we just print this out once at the very end. No reason to print that out for every single one. Added a delimiter here, so when we're doing an expression, we actually can see if there's white space and whatnot. It was not entirely clear where the white space was before, so we just did a small change there. Got rid of a redundant message, redundant error or result printout here. That comment seemed superfluous. We're looking for the plus sign. We don't need to say we're looking for the plus sign, especially if we're going to have a dozen of these different operators we're looking at. Minor cleanup with the message here. It was a little too fancy for my taste, so I just did some minor cleanup there. Got rid of these magic numbers. So instead of referring to token 0 throughout the code, I pulled it out instead. Let's see, changed this a little bit here. This was a variable lookup, so instead of putting it result, we're just saying value. So a variable lookup, variable value. In fact, I might be tempted to change the word lookup and just say variable. Let's go see what that looks like. Okay, craps, eval, print, balance. Yeah, evaluating tokens, identifier balance, variable balance, value, float 9519. I think that looks fine. Now we have variable name, variable value. Continue to look for that here. Yeah, so this is what I just did. I just got rid of the word lookup. Frosty says, there, done with the raid, so now I can hear you. Well, hey, welcome back to the stream. How's it going? Yeah, change result to value there. Got rid of the magic number here and just went with the token variable. Handle the plus operator. Yeah, so here I actually pulled out the function into a new function. So we still have this return eval operator, but that does all the work that used to be done here. Here's the eval operator. You can see some of the same code. Frosty says, I've been here the whole time. Glad to see you already, so I didn't really leave. Well, cool. Glad you're able to hang out, and now you're able to hear me, so even better. Again, let's see. Looks like I still have... Nope, I got rid of the magic number here as well. So we have operator token. Could possibly make that even simpler, going with token, but I think operator token makes more sense. Let's see, we've changed a lot of debugging here. We've just kind of pulled some stuff out here. So if it's plus, we now set operation type and operation function. If it's greater than, we set operation type, operation function. Error message, expected operator, but got this other thing instead. Return null. We handle left value, right value. Some of this just got re-indented a little bit because we pulled it out from its own function. Let's see, then we have types. Oh yes, we got rid of the type check in here. We're doing that in the operation's own functions. We set the message, we print the message. We call the operation function. If the result is null, we return null, otherwise we print the result. And this is one of the few places where we actually print the result. Again, I'm trying to get rid of all the duplicate result printing, so this is one of these places where it's deep in the system and we do print the result here. Then we've added plus operation. The diff is doing some weird stuff down here because Git is confused with the work I've been doing. But we just built up some very specific functions. So we have plus operation, greater than operation. As I add new operators, I'll add new independent functions for all of these and hopefully make it easier to add new operators. It's always a challenge trying to keep the code clean and refactored and easy to work with. I used to be more explicit with my type checks of plus, where I would require all of the operands to be the same type. I've now I've eliminated that, so you can do a plus with an integer and a float. If you do, you get a float. Otherwise, if you just do a pure integer add, it just returns an integer. That's what this type is doing down here, is to do the operator or the number integer promotion to float. Greater than, very similar. We check to make sure we have either an integer or a float for both operands. The fact that these two checks are very similar implies I might want to do a bit of refactoring on that as well. We'll see. Because that'll be the same case for minus and multiplied. Well, multiplied divide might be a little bit different. We'll just see. For now, it's just the two cases. As I add more cases, I'll probably want to refactor some of this. And then boom, return the comparison, return type Boolean, value, left value is greater than right value. Add support for greater than operator. Not that many insertions, just a lot of deletions, a lot of things got changed with that. Things are definitely getting a lot easier to add these new concepts. So the idea I'm working towards is to be able to create this program concept. You want to be able to create a program, add these conditions to the program. In this case, the condition is balance is greater than 9,000. That's the condition, and then the action is to bet any 7 for the max amount, and then run the program. So these are kind of the next things I want to add. Kind of a big block of stuff. You see, FriesD says as the highest damage per second in the raid, 20.3k versus 17.5. Nice work. That's great. So this is kind of the next major task I want to work on, is to add the concept of programs, to add these conditions, and then run them. The idea being that every die roll will check all these conditions, and any condition that matches, that returns true, will then perform the corresponding action. In this case, this is kind of a really bad program here, at least for making money, because any 7 is probably the worst bet in my game, because you have a really bad payout and it has a really high house edge. And so it's kind of one of the things I've been playing with. I've been experimenting with making bad bets and trying to transfer a lot of money over to whoever the banker is, just just as I can, just as an experiment and a test and whatnot. And so that's basically what this does, is to basically say, as long as my balance is over 9,000, make this bet. As soon as my balance drops below that, it'll stop making the bet. And then we can think about other conditions to add more nuance to that, based on just things we want to do. So that's kind of the goal. I don't think I'm quite ready to hop into that block of work right now. I've been streaming for about 5 hours. Frosty says, it's over 9,000! Yes, my balance is over 9,000! It's from something. I forget what it is, some movie or something, I think. Yeah, I'm not quite prepared to hop into the program creation yet. I've done a lot of kind of hard work already today with adding the tokenizer, parser, evaluation engine, and it's actually working halfway decent for the moment. It's really naive. I don't handle operator precedence yet, or operator ordering or anything like that. I don't handle parentheses. I only handle plus and greater than. So definitely more work to do, but I kind of want to work towards these program concepts. Oh, Frosty says it's from Dragon Ball. Nice. Yeah, I haven't seen that one, so that's probably why I've heard of the meme, but I haven't seen the series actually. So that's why I'm not as familiar with it. And so yeah, I think that's kind of where I want to go next, is maybe save this next block of work for another stream when I'm a little more fresh and have a little more time, because I don't want to hop into this and you have to run halfway through. So I think this is a good time for me to wrap up today's stream. Just kind of review what I've done so far today. I started expression parsing logic, starting with the plus operator. So I got plus working. I added the ability to evaluate literal integers. And I've added support for the greater than operator. So we've got some very basic parsing logic in place. And it's all beginning to come together. We've also done some cleanup with the error handling and the result printouts and whatnot. And so just kind of slowly evolving this over time. Bit of a Frankenstein monster for the moment. That's kind of how I work. I just add whatever comes to mind at the time and slowly clean things up and refactor it as I see what makes sense. All right, let's go ahead and push this work to GitHub here. I'm behind by 3 commits. Go make sure that shows up on GitHub over here. Up to 91 commits. There they all are. If anyone wants to check out the code, you can go to github.com/queuedpixel/twitchcrapsbot. I'll send a link in chat here real fast so people can click on that link as well if they would prefer. As always, this is my regular stream schedule. I stream regularly on Sunday mornings at 9 a.m. And so you can see I've been going for just over 5 hours a day. I do sometimes will stream weekday afternoons and evenings when possible. My schedule's hard to predict during the week, so it's tough for me to commit to specific streams during the week. But I have been pretty good about streaming on Sundays. Frosty says, oh, not so nice Team Flash with the white dude. I guess I do need to make a dark version of my stream schedule here. Apologies for that. I don't think about stuff like that. I will work on a dark version of that for the future. I just kind of did whatever was easy when I built this the first time a few months ago. Well, that's where I'm at. Thank you for checking me out. I'll definitely be back 1 week from today at 9 a.m. on Sunday, July 14th. Might be back between now and then during the week. We will see. Thank you for checking me out, and I will see you next time.